Okay, now we're on to part D. For the time period 0 to 8, is there a time when the rate at which water is pumped in, so the in rate again is W, so we're wondering, is there a time when W is the same or equal to the rate at which water is removed? So they're wondering, is there ever a time when W has the same value as R? I will be honest, without looking at the answer on this problem, I really got stuck. It's a really good example of why I never would claim to be able to get 100% every point correct on the AP test. They just will always come up with some problem that's clever. So I'm going to explain it, but make sure that you don't overstress on this one. This one definitely falls into the category of we don't care that we lose a point here. We don't want to waste time trying to get these two measly points when we could be earning many other points which were much easier. In this number 1 FRQ, always worth 9 points for any FRQ, and I would say the first 7 weren't bad at all, but these last 2 were hard. And the hard one isn't always part D, it's just somewhere in the problem sometimes, so just make sure if you run into something hard, you just move on quickly. But anyway, the way they actually found, the way they justified their answer is they noted that the rate of outgoing, the out rate at time 0 is 1340. The in rate at time 0, they calculate that using the formula. That turns out to be 2000. So that tells us that in rate subtract out rate starts out positive. Then they note that at the end of the 8 hours, they look up the out rate and they calculate the in rate, and now we see that the in rate subtract the out rate is now a negative number. So they're thinking of in rate subtract out rate. That's what I was calling a prime. So basically we're trying to see, is there ever a time when a prime is equal to 0? So it's really an intermediate value problem. Like that's what you see here in their answer. I don't know that I could have ever figured this one out. I just couldn't kind of wrap my head around what they were trying to say. But basically they're saying that a prime is negative, is positive at time 0, and then a prime, here's a prime again, is negative at time 8. Therefore, since this function is continuous, W, and R is also continuous since R is differentiable, the intermediate value theorem guarantees that because the value of a prime was initially positive and then the value of a prime switches to negative, there must have been a time when a prime was actually equal to 0. That's what they're saying with all of this wording here. There had to have been a time when a prime, here's a prime, is equal to 0 by the intermediate value theorem. If a prime is ever equal to 0, that would be the moment when the in rate and the out rate are the same. So that's how you'd earn the 2 points on that one, is by, you'd have to state something about the intermediate value theorem, and you have to make an argument that you're looking for that time when a prime is 0, or you can do it the way they did it. That's 2 total points.